Hello, I'm Ian and welcome to the new build.
Ian, thank you for inviting us into your new build.
Pleasure.
We understand that you took a lot of time in designing features into the house that would make it more sustainable.
Yep.
Would you like to share some of those thoughts with us?
Yeah, sure. When we started on this journey, I guess we were informed by a couple of previous builds, and so we were keen to have a concrete slab from a thermal mass point of view. We were keen to have a steel frame because we'd had timber frames before and had some pretty serious termite problems. And we were keen to have a lightweight cladded home. So they were some of the design sort of requirements. And with that came a few challenges because steel frames in particular conduct so that you need to thermally break them. And they can also create cold spots, which is an opportunity for condensation. So I say when I started the project, I wasn't as aware of the need for thermal breaking as I became aware as we were into the project. So probably not the ideal way to do it. So we landed up going down a few different pathways, but we landed on a situation where the house was effectively wrapped in a pretty sophisticated membrane, which is a product that Kingspan make, and it's a has three parts to the product. It's a thermal break, it's an insulation, well it's probably four actually. It's got a moisture, it's moisture permeable in one direction, and it's waterproof in the other.
Excellent.
So the entire building is wrapped in that, including all the gable ends, everything's done in that. And so that provided an effective thermal break for the frame, and it helped the insulative value of the walls as well. And then the roof had a similar approach, but it had an anti-condensation blanket over the back sort of half of the house has got traditional truss frames. The front part of the house, which has got the rake ceilings, they've got web trusses, so you don't have the same clear space available there. But the anti-condensation blanket deals with condensation that can form underneath the tin from a temperature, and then it wicks away and drains out into the gutter.
Yeah.
But it also provides an insulation as well. But on the other side with that, the steel frame, if you will, is the risk of the condensation, which is really around the relative humidity and the dew point. So here, the dew point actually is very often pretty much at or just above the ambient temperature. So the likelihood of condensation in this environment is really high. You don't have to do much to get it. And so there's two ways to kind of manage it. One is to manage the humidity within the home. So there's a fully ducted reverse cycle split system. So that can pull the humidity out. But the other way is also to provide some ventilation to it, particularly in the roof cavity. So the roof's got a lot of houses these days, like mass-produced houses, have got what they call whirlybirds, sort of a round thing that spin. I didn't like the look of those, so I wanted to avoid that. So we installed a permanent, a ridge that's got a permanent venting in it. So it's got a sort of a folded piece of material that's slotted, and that goes over the end of the tin, and then the cap sits over the top of it. So there's always a way for the air to escape along the entire length of the ridge. And it draws air in because there's a way for the air to come in through the eaves. So that's really important, and so that seems to be working really well. And then on the concrete slab, I suppose going back to the concrete slab, which is where it all started, it's a waffle slab, but instead of using styrene, we used a modular recycled plastic 600 diameter sort of chairs, if you like, and we used a reflective waterproof membrane under that, which improves the R rating of the slab by about R1.5.
Yes.
And so effectively under the slab there's all these trapped air pockets through it.
Excellent. Because condensation is a major problem because it causes mould.
Correct.
Which is a health hazard.
Yep.
Something to be avoided at all costs.
Yep.
When you were selecting your windows, what did you look for there?
We didn't go with thermally broken window frames.
Mm-hmm.
And it's like a lot of things in the building, there's sort of pluses and minuses for doing things. Like a timber frame is good because it is thermally broken, but a timber frame has maintenance, and I'm really keen to have as little maintenance as possible. So it's all pre-finished, pre-done, so there kind of is no maintenance apart from a bit of cleaning. But to run with thermally broken window frames, it was around about an uplift cost of about 100%, roughly 100%, double the price for the windows. And we were running a budget on the place, so it's not that we couldn't have afforded to do it, but we looked at it and thought, well, okay, what are the other options? If we do go with non-thermally broken windows, frames, what's the consequence? And the consequence is that because aluminium is such a good conductor, you get sort of ambient transfer. Mm-hmm. So if the temperature is pleasant, let's say it's 20 or 21, then the ambient transfer is irrelevant because it doesn't matter. If it's say 0 or 4 or quite cool, then the frames will be cold, and they are actually transferring that temperature into the house. Then if it's in the winter, say, and the sun is there, or in the summer and the sun's there, you get the radiant heat, and the frames will start to warm up. And in the summer they can get quite warm.
Yeah.
Not so much the ambient, but it's the if the sun's hitting that frame on the outside, you'll feel it on the inside. The frame will be warmer than the glass. The frame will be colder than the glass. So, in any event, and we decided that we could effectively insulate these windows using honeycomb blinds in many applications. My wife wanted some design freedom, so we didn't put them in a couple of windows. They're just a sort of a block-out blind, so they're not as effective as the honeycomb blind. And in the bedroom we had a traditional curtain, which is very effective.
Yeah. So effectively you've added not double glazing in your honeycomb blinds, but you've created air pockets similar to double glazing. Yeah, kind of. And the upside that we're finding is that in the winter, because even though the house has got a lot of trees to the north and we didn't want to remove those, in the winter the sun angle is such that the sun's coming and hitting all of this glass, and so in the summer when it's sunny you're actually getting these window frames producing warmth, which is what you want. Yeah. In the summer, the sun's a lot higher, and I did compromise a bit here with the eaves, so that they're not fully protected for the sun. Mm-hmm. But I can manage that heat gain with the honeycombs for an hour and a half a day, if needs be. So it's sort of, I guess the only other issue with the non-thermally broken window is the potential for condensation forming on the aluminium. Well, in the bedroom, we didn't go with a sort of a fully sealed house, although it is fairly sealed. And in the bedroom at night, we sleep with the window slightly open, so there's no condensation issue. We've had no condensation issues in the house, and we've been in since October 24. So we've had some pretty hot months, we've had some very cold months. I've seen no condensation whatsoever inside, so I think it's worked out okay.